Sorry if I'm a little bit of harmonic feedback, but if you have the slides, I will not walk in the way of the QR code, but you can take the QR code so that if I don't get to certain slides, you can take a look at them afterwards. There's also a lot of stuff that is clickable that didn't fit into a QR code because a lot of it is like, it's too large. The content length is too large for it. So with that, I'm going to kick into the slides. So I'm Scott. I've worked at a lot of different companies before getting into like developer relations engineering. I've written a lot of books over the years. I like to share the things that I've learned with people. I was part of like the inaugural like Databricks Beacons program. I've been part of the Databricks like MVP program for a long time as well. And I like to give back to the community and teach people things. So for today, we're going to go through some streaming data design patterns. And it's essentially like, if we think about like a mission for like what we're trying to do today, it's to iceberg or bust. Yay. We're going to talk about consistent streaming ingestion with protobuf. If people haven't used protobuf, that's okay. I want to make it pretty simple. And then we're going to talk about Spark structured streaming. So if you haven't used Spark before, I'm going to try and also make that simple. And then I'll also give you like a sales pitch for the company that I work at. I'll make that really short at the very end, so you don't have to get to that if you don't want to. But if you want to download the slides, that's good. My head's not in the way, which is awesome. So I'm going to kick into it. So if you think about like streaming architecture, everyone's probably seen something similar to this before. Somebody is sending data that's going somewhere. We're going to validate it. It's going to go to a dead letter queue or a dead letter topic or a dead letter table, depending on what you're using. And it's going to also go down a happy path that's going to eventually end up in, a table format. Like Iceberg. We're at an Iceberg Meetup. So we're going to talk about that. So this is essentially like a consistent streaming ingestion pipeline. It's pretty simple. So people who aren't in like the protobuf community, I'm like, I don't have a pointer. I'm like, this is a pointer. Maybe this is, there we go. That's protobuf. Protobuf is just a different way of serializing data. So if you are sending JSON data, or if you're sending CSV or Avro, protobuf is just another way of doing that. Sorry, I'm skipping ahead. So what is it that all streaming processing, what do all streaming processing engines have in common? It's data. So when you think about that, it's like, it's a big deal to make the data correct. So what it is like that we want to do with the data matters a lot. I'm double skipping through this. So essentially, why protobuf, right? Has anybody in this room ever used protobuf for anything? Yes. All right. It's always around like a 10% type thing, which is okay. So protobuf, if you've ever used JSON and anyone's ever switched the JSON out from beneath you, you can blame the upstream or you can do something about it. And so for a lot of times, if you think about protobuf, the end result of that serialization looks a lot like JSON, but you have different kind of semantic guarantees and ways of validating that data that don't necessarily come with JSON just because you have, a different format for all of that. So protobuf is type safe. It's language agnostic. So you use whatever you're happy with. And it's also binary serializable, which means that you can send it, you can store it, and you can go back to it at a later point in time, and it still knows exactly what it was at that point in time. So a lot of the things that we do when we take data and we stream it, we care a lot about binary serializability. We also care about whether or not we can send very compact data payloads. I don't have to go into the rest of the stuff as well. If you download the slides, you can also read through it as well. So I'm not just going to read off the slides, but on the right-hand side, we have like a typical protobuf message. I like coffee. A couple of years ago, I wrote an entire coffee like store e-commerce system based off of protobuf, and I shared it with the Data AI Summit. So this is essentially me stealing from my old slides as well. But if you have a store has a location, a store has an identifier, a store has timestamps where was it created? That has to be if you're going to walk into it. Is it open? Is it closed? Is it closed permanently? There's all different kind of states in your data, and those states of data matter. And that states of data also matter when it actually is translated into what's actually in the database table. So what we have here is essentially something that can turn directly into a database table. And we're going to see that as we go through this as well. Hold on. Share this anyways. Hold on. All right. So interesting. My slides are now corrupt as well, which is interesting because it's showing up on the JSON slide. So if people have ever done streaming with JSON before, little changes in the actual schema itself can corrupt your JSON. So what I had over here with like small change corrupt impact, I can hand wave through it because it didn't load on the slide. But on the top one, it's like, here's what my JSON was in like, say, version 1. Somebody's made a change and now it's corrupt. It might be as easy as essentially creating like a nested field. And that nested field wasn't something that people actually thought about. And so if you're making changes outside of people knowing about it, it's going to break your systems downstream. So JSON is easily corruptible. And you're going to find out that almost everything's easily corruptible. So Avro is also easily corruptible. If you've used Avro before, you've probably seen array index out of bounds exceptions because data changes. Avro doesn't like nested fields, and that's okay. Like every single kind of processing engine that's dealt with different formats has found their way around these problems. So if you've used like permissive pass-through, if you've done any kind of like, it's like, I'm just going to ignore corrupt files. Like that's an entire, literally like application level config within Spark that lets you just ignore things that go bad. So that's cool, right? We know that things break. It's not anyone's fault. It's like, it is people's fault, but it's not actually their fault when certain things happen because you can recover from it unless it's all completely broken. And so we have workarounds, but it's really bad when like you go from a pipeline that's, millions of rows per second and it goes to 0. And you're like, well, what happened? It's like, well, we're throwing away everything because we're ignoring those corrupt fields. So Protobuf also has its faults. I'm talking about Protobuf because I work at a company called Buff, but Protobuf is also problematic as well. Like if you change the schema and you introduce a breaking change, you've broken the wire format. If you break the wire format, you no longer have a stream that's working, but all right, that's okay. There's workarounds for that. Who here uses Spark? Awesome. Who here uses like Flink or anything else like that? Who here is new to streaming? Awesome. So everybody who didn't raise their hands, that's okay as well. Participation is not important. The big thing is that we care more about like, how things work, right? And no matter what streaming engine you're using, like there's serializers and deserializers that come along with the work that you're doing. And so if everything has its faults, that's okay. But if you don't have to worry about those faults, that's even better. And so if you think about data quality, right? Every talk is always about like, hey, it's data quality, right? Things need to work. You need to be able to trust your data. And if you want to trust your data, then you can't have surprise changes because then you break downstream consumers and you get angry. They've never been super happy about like having to go and fix anything. But you're going to embed trust. And it's really easy to break trust, erode trust if things keep on breaking. And then you also get bad turnover at whatever company you're working at. So for Protobuf, if you're using Protobuf, we have breaking change detection. If you've used things like Delta, if you've used things like Iceberg, then you also have essentially like schema enforcement and ways of actually evolving your schemas. So with Protobuf, you have the same way of doing all of that. And so it's interesting if you think about Iceberg and you think about like, write, audit, publish type patterns, you don't have to do that for foundational data as long as you can trust that your data is not breaking and it's continuing to act in the way that it should act. And so hopefully you can see that. If you can't see in the back, you can also download the slides. I'll post about it afterwards as well, but we have like a free tool. It's open source. And so if you're using Protobuf, you can use something called buff breaking. Maybe you change detection against essentially either yourself if you're looking at like a local GitHub tag, like a GitHub head, or you can go against GitHub tags. You can go against like pretty much anything in general. It's a pretty flexible tool. But it makes it really easy to say like, I trust that my change is not going to break my downstream. I can go publish this and I can work with it. And the nice thing about Protobuf is it's backwards and forwards compatible. And so backwards compatibility you have with Avro, but you also have array index out of bounds exceptions because there's no forwards compatibility. And so with Protobuf, you have forwards compatibility because you can just ignore things it doesn't know, which is also cool. So it allows you to essentially do like asynchronous deployments across your entire stack. You eventually can catch up, and then that can also, relate back into your actual database tables themselves. So use breaking change detection, and that also fixes the problem of like how Protobuf also has faults because I can't be like Protobuf is great because everything can break. So this works, you don't have to. All right, moving on. So Protobuf is an interesting thing because it essentially gives you like, shape and schema compatibility guarantees, but it doesn't really care about what the values are. If you think about data quality, or like, sort of like, data observability of like what's changing, what's being used, et cetera, you have to really worry about, semantically, what's that data? What are the values themselves? And so it's like, there's a lot of quotes for like icebergs and the Titanic. This is a Gemini quick and like, make a ship crashing into an iceberg. And it's like, here, I don't know if that laser shows up, but I was thinking about this a lot because it's like data quality you can have everything else working really well, but you can still like, rock the boat and destroy things. And people still get mad. So you're not breaking downstream. You're also breaking like, your downstream customers' expectations. Don't sink that ship. I don't know if you can see this in the back, but there's something called Proto-Validate. The actual Proto-Validate project itself, it's open source. It works with the Buff toolchain. It also came out of like the Envoy project itself. So like Envoy used this to essentially, validate that things were working within like, I don't know, any kind of load balancers and things like that to do like correct routing. But it also goes for your data. And so I'm sure no one can see any of this stuff, but if I have the same store that I showed before, it's a basic store. It has an identifier. It can open, it can close, it can permanently close. That's all great. But you can also write expressions. So I can say like, sorry, like I want to hear my voice so that everyone else can also hear it as well. But so if I'm going to open on, I want to make sure that I've created a record first, or it's equal to when I created it. So it's like, I have this ID that's like, open on exists. Open is greater than you created at. This would be kind of complicated if you have to let it out in like every format that you're using to essentially, parse your data. And then if you wanted to have like compound validation rules, that'd be even harder to do as well. And so the big thing is like, we don't have to really worry about how this works. We know that it works. And because Proto-F itself is language agnostic, the way that Proto-Validate will work, it will look across every single language in exactly the same way. So you don't have to worry about how we're parsing long values or anything else like that across specific types of languages, but it's always the same, which is interesting. It's also free. We also have this playground called protovalidate.com, and we look time-wise, like the timer's not running, but that's okay. I don't know how much time we have left, so I can show this stuff at the end, but protovalidate.com lets you essentially create your Proto-F, play with Proto-Validate, do anything else you want, and it does it all through essentially WebAssembly, so you don't have to actually do anything. You can just click on this and take a look at the whole entire thing that I'm showing right now, and it's really fun. But how does this matter for Iceberg? We'll skip through this part because I'm showing them a lot at a time. And for this part, you could give it a try, but this didn't fit in the QR code. This is where I ran out of essentially like, I would have like, it's like the 40, 48 like limit or whatever else is for content length. Because we're encoding all the Proto-F, all the is, we're encoding like a JSON body, so that we can essentially share these things back and forth. It's too big to share easily. So in the side, you can click on it, it's fun. But it lets you essentially have a playground where instead of using just JSON, you can play around with Proto-Buff. You don't have to do anything else with it. Be like, does this work or not? It's just neat. So Proto-Buff and Proto-Validate mean you can write out it, publish for foundational data. As long as you're using it before you're queuing data into something like Kafka, or if, however else you're getting data into, Iceberg itself, which we're going to go through as well. And awesome. The timer, thank you for that. I have time to actually go through the rest of this, which is awesome. So what edit publish is still going to be important for everything you do after essentially writing to your foundational Iceberg tables. That for everybody who's working big enterprises, like I came from Nike before this, and we had like 1 million tables. A lot of those tables were all foundational, and we would essentially write to them, and we would rarely change the schema or anything else like that. And that would be essentially the starting point for all other data that, one can use within the company. If we had to worry about like whether or not those base foundational tables were correct or not, it would make it really difficult to essentially fix anything in triage things. We'd say it'd actually be in cycles where like 60 to 80% of engineering time was spent essentially fixing stupid problems. And so by using Proto-F and Proto-Validate, it's much easier to be able to not fix stupid problems and focus on things that are more fun. I think this is a corrupt slide as well. So I don't know why this is happening. This is okay. I'm sure it works. I did look at these slides before I was presenting. So client-side validation for Kafka. It's not loading for some reason, like off of the Google slide. And so I'll just explain what this slide said. So essentially, we have an RPC function inside of a gRPC application. One of those functions is us essentially taking a coffee order. I'm getting a coffee order. That's awesome. If I want to be able to validate that order before queuing it to Kafka, I need to do that on the client side. And so, hopefully people can follow the hand wave because of the unrendering slide. But if I want to call like a validation method on that, and I want to do that for all essential data entities or anything else that I have, I might have to create a million validation rules. If I can encode those directly in my protobuf and I can actually just compile those using CodeGen, that's much easier. And so if you get nothing else out of this whole entire presentation, CodeGen validation rules before you queue to Kafka, and then all of your data is essentially consistent, and you never have to worry about the problems with that initial write, if you do things correctly. And I can explain more of that outside of this talk because I've got 9 minutes left. So let's go to Apache Spark structured streaming. So the first part of this entire talk so far is essentially on data is the most important thing that we're going to put into Iceberg. And so the thing you should spend a lot of the time on is making sure that that data is accurate and consistent and can be evolved without breaking our prior tables. And that's also really an important thing to think about too if you think about structured streaming. I know not a lot of people in here are using Spark on a daily basis. But one of the things that's essentially a limit to Spark structured streaming is that I really can only take a look at doing append transactions to an Iceberg table based off of its main branch. And so if you think about that, that rule is actually nice for any kind of other late audit published patterns or anything else like that. It just means that we're not really talking about real time when we're talking about this streaming in the same way that we would if we think about kind of a discrete continuous stream of other data in other systems. So with Spark structured streaming, you have to still pay the piper when it comes to actually committing and writing transactions. And so you take a look at that right now. If it loads, hold on. I'm just going to hold on one sec. I'm just going to see if I reload all of this. Do I get my data? I'm getting data. Hold on one sec. ESA. Yeah, this feels better. Okay. Yeah, it's loading it. Awesome. So this has never happened before. I'm all right, it's probably a lie, right? But anyways, so Iceberg catalog connections, right? The way that we connect to our Iceberg catalogs is going to be through the Spark configuration. And so with a Spark configuration, I don't have to go through all of this, but this is connected to the catalog in Databricks. And so I've got a Spark catalog. I've got a REST OAuth2 connection that can authenticate for my user. I've got a workspace. Within that workspace, I have a token service so that I can actually, I can do my authentication. Yay. I've got a credential. This credential is using a service principal. If anyone wants to ask questions about all this stuff later, feel free to. And we will also have a base Unity catalog warehouse. So you can see a lot of the same stuff you'll see whether you're in Nessie, you're in Lakekeep or anything else like that. We're essentially just setting up catalog configuration for permissions. And that's cool, right? And so we can now connect to the catalog, which means we can write to the catalog. If we want to be able to read our data in from Kafka, I don't have I don't have that example in the same way. This one is more kind of showing a string to string connection from one Iceberg table to another Iceberg table. But if you've used Spark before, you can ignore this Iceberg and say Kafka. And then we still have rate limiters and everything else like that for reading off of the Kafka topic. So in this case, you're saying I'm going to read, and I'm going to essentially limit files per batch. I'm doing that to essentially not have out-of-memory exceptions, because out-of-memory exceptions are bad because your whole entire application breaks, and that's not fun. And so it's interesting too, because if you think about what does an optimized compacted file contain within your Iceberg table? If you take a look at just reading one file, you can start to understand more about what the shape of the data looks like, and also what the volume of your data looks like. And so in certain cases, you might have a million actual rows of data per file. And so if you're I'm going to go pull on 1,000 files, and I don't want to rate limit any of this stuff, you're going to do bust real quick. You don't want to have anything else explode. So a lot of things that make it easier when you're first getting into streaming is the ability to actually rate limit. So you start off small and you incrementally essentially change your configurations until you break again. And then you incrementally change and you change until you get to the point where you're comfortable being able to consume the data and also write it. Because there's a write tax with Iceberg because of the manifest and the way that everything needs to be written. And so if we were in the meeting, not the meeting, but if you were in the panel discussions this morning, there's ways of making Iceberg faster in terms of commits that are coming. But right now, it still takes a little bit of time to commit. So for structured streaming, it's going to run a little bit behind what you'd expect if you just do straight Kafka to Kafka type streaming. or if you're using a different engine that's been written specifically for speed. But with that said, it really depends on how fast you actually need to stream. And so not everybody has to stream, in microseconds or anything else like that. It's actually like a mental model that makes it just easier if you think about streaming microbatch. Like, I want to be able to push data through the system in a consistent way, but I don't really want to think about having to actually provide all the metadata to be able to continuously move through batches. Like, if I had to keep track of the last snapshot manually, that's a pain in the ass. But if I can have Spark do that for me, they'll connect directly to the checkpoints, and I don't have to think about it. The less I have to think about, the easier it is for me to automate. So rate limiting for readers are essentially preventing out-of-memory exceptions, and it's essentially saying, like, from snapshot to snapshot, how fast do I want to move? How much has changed since the last time I've actually picked up and I've streamed, which is interesting. I'll skip the rest of the settings other than streaming max files per microbatch is important. Max rows per microbatch also allows you to take a look at essentially breaking up files as you're reading, so that you might be reading the same file for a couple iterations, but that's okay. But the thing that matters until you actually get into triggering. And so I'll skip the erase run because of the 3 minutes I have left to finish this whole presentation. But if you download your slides, which I showed at the end again, there's some interesting ways of essentially treating your snapshots in the same way that you would Kafka, for example. I want to start from earliest, or I want to go from latest, etc. It's kind of fun. So it's just a trick. If you want to control the writers, right? The writer itself has triggers. A trigger allows you to essentially control how often you're taking batches of data and you're writing that data. And so if you think about being able to write to the Iceberg, data format, there's going to be a little bit of overhead. And so instead of buffering using processing time or process time, which people have probably done before, where you're kind of waiting in real time for the next batch to tick. So if I have no new data and I'm cool, I'm going to wait a minute. I'm going to wait 5 minutes between runs. It's a stupid waste of time. If I want to sit there and say, is there a new transaction? It hits the REST catalog and says no. Cool. I can sit there and basically poll, and it's a pretty cheap operation. But if I need to respect my throttles, when Trigger Available Now just literally came out this month, or I guess now it's October, the last month, which lets you essentially catch up using your actual rate limiters so that you can essentially run things without running out of memory. And essentially, if you wanted to do replay jobs, anything else like that, you go back in time, you reprocess all your data. He's also helpful for figuring out how much do you want to actually scale, the streaming pipelines. So you can control different behavior depending on the way that the table's been set up as well. So if you're using FAT enabled, you're able to actually write to different partitions without having to essentially sort everything in place beforehand. And then, if I'm doing streaming to table, I can stream directly to a managed table as well, which is nice. So, all right, 2 minutes, this is going to be good. So trigger happy, I'm going to go fast from here. So trigger processing time with a duration is the way that things work. Available now is now available, which is nice if you want to run things in the same way that you would a normal batch. And without doing trigger once processing, for people who are familiar with that, it allows you to catch up, and that's really nice, the cool feature to have. The other interesting thing too is if I do trigger available now processing, it's going to always run through everything that's available. So it might be 2 or 3 snapshots it's catching up on. After that, you can run any of your straight procedures or anything else like that in Iceberg to optimize your table. And then you just essentially repeat the cycle, which makes everybody happy, which is nice. So lessons learned, rate limiting prevents out-of-memory exceptions, optimizing the flow data to Iceberg for the data stream, either data stream later, with specific options that allow you to essentially tune and kind of do, flight controlling of the actual stream. Trigger available now is available now, which is nice as of me talking about this. And that really helps you to actually reprocess and get ready for streaming if you haven't been streaming before. And then the little quick sales pitch, which I got 40 seconds for. I work at a company called Beth. We have another Kafka compatible API that's protobuf first. It actually uses only protobuf. So if you're in the protobuf ecosystem and you want to essentially stream directly to Iceberg, then you do that as well. So the other interesting thing too is early on in the conversation, I talked about proto validate. And so we actually do something called broker side semantic validation. So rather than having every single client that's writing to Kafka actually implement some sort of validation logic, it's actually done in the memory of the actual broker itself. So it's very easy. And that's kind of my sales pitch. You can reach out if you want to find out more. I guess I should probably talk about this even though I'm at time. So you're also an official launch partner. I've managed Iceberg and Databricks as well. There's a bunch of other companies here that are also launch partners. If you are using Databricks and you want to stream consistent data, you can use BuffStream as another option as well. And so with that, that's it. So if you want to download the slides to catch up on anything or reach out, feel free. But thank you.